Hello class, in this video we are going to learn how to find expected values. Let's take a look at this problem. An oil company is considering two sites on which to drill. The sites are described in the following table. This is the information about site A and this is information about site B. And we need to determine which site has the larger expected profit. Select the correct answer below, and if necessary, fill in the answer box to complete your answer. Okay, so we have two plans, site A and site B. We are going to construct the probability distribution table for each option. And the random variable x here is going to represent the profit. Right? Profit is positive if you have the gain. Profit is negative if you have the loss, if you lose money. So for plan A, site A, I always make a 4-column tables. The first column is the cases or outcomes. Second column is the random variable profit. So knowing, remember X represent profit. And the next column is the PROB, probability. And the last column is the product. What happens if we choose to drill site A? Either, the site has oil or no oil, right? So two outcomes, either has oil or no oil, or success or failure, right? So in the case the site has oil, then the profit, see, profit if oil is found is 50 million. We are going to ignore the million and then attach back later, okay? Everything has a million on it. So just do 50 million. So if the oil is found in site A, the profit is 50 million, so 50. If the oil is not found in the site, then the loss is 2 million. Loss is 2 million means the profit X is a negative 20. Sorry, negative 2, apologize. Negative 2. So profit is negative 2 million, means the loss is 2 million. The probability of finding oil is 0.2. Then the probability not finding oil would be 0.8. The probabilities in the column must add up to 1. All right, so we have the center, the middle two terms actually give the probability distribution table for random variable X. Now we're going to find the product for each case. First row, we multiply 50 by 0.2. That gives us 10. Right? 50 times 0.2. Second row, we multiply negative 2 by 0.8. That gives us a negative 1.6. And we are going to add the two products together, 10 plus negative 1.6, and that is 8.4. 8.4 what? Million. Now we attach the $1 million back. So if the company decides to drill site A, they expect to have 8.4 million profit. So that is site A. Now let's look at site B. Same thing. We're going to construct the table. The table is going to have 4 columns. First column, outcomes or cases. When the company drills site B, is the same thing. Either find oil or end up not finding oil. So no oil found. 2 cases. And the second column is all the possible values for variable X, for the random variable X. Again, random variable X represents profit. Let's look at the information about site B. Profit if oil is found 75 million. Profit is 75 million. If the oil is not found in side B, the loss is 19 million. So the profit is a negative 19. Next column is the probabilities for each case. When the oil is found, what's the chance of the oil is found? It says the probability of finding oil is 0.1. Then the probability of not finding oil would be 0.9, right? The two probabilities must add up to 1. The last column is going to be the product. Same with earlier, the middle two terms. The middle two columns gives the probability distribution table. To find the product, we multiply 75 by 0.1, that is 7.5. We multiply negative 19 by 0.9. Seventeen point one, so negative 17.1. 19 times. Yeah, I think so. 1.9. Yeah, okay. So the expected value of the profit, or the expected profit, would be the addition of the two products. 7.5 plus negative 17.1, so minus 17.1. As you can see, wow, this time we would have a negative. Wait a second, let me double check. 75, so 0.1. 0.1 is 7.5. And negative 19. Loss is 19 million, is very significant. And the chance of not finding oil is very high. It's very risky, right? The plan B. 0.9. So it is negative 17. Okay, so this time we're gonna negative. Let's see, 17.1 minus 7.5. That is 6. 9 minus 7 is 2. 12. Hold on. 17 is 6. No. So 6, 16 is 9. Okay. 9.6. Double check the calculation. Yep. So negative 9.6 million. So side B, the expected profit is negative. Okay. 19 million. Okay, so of course you choose side A, right? Excuse me. Of course you choose side A. By how much? Because the expected profit for side A is a lot higher. By how much? Okay, I understand what's the confusion part for some of you. So the expected profit for side A is 8.4. Expected profit for side B is a negative 9.6. And what's the difference between those two numbers? We need to use 8.4 to minus negative 9.6. So actually we are adding 8.4 and 9.6 together. So that gives us 18. Okay, 18 million. The difference is 18 million. I can also use a real number line to explain. So this is 0, right? The expected profit for side A, 8.4. That is right here, 8.4. And the expected profit for side B is a negative 9.6. Is below 0. It's right here. So what's the difference between those two values? You are actually adding the absolute values, their absolute values together, 8.4 plus 9.6, because this is negative. All right, your minus negative actually is adding the positive. So side A has a larger expected value, expected profit by 18 million. Let me go to enter the answer here. that A has a larger expected profit by 18 million. Is it correct? I hope this explanation helps. I'll see you next time.